I'm going to work through some genetics problem with you guys. Now, I put a Word file for these questions in Blackboard for you and recommended that you try them on your own first. And now I'm going to walk you through the solutions to these questions. And certainly if I'm going over one that you're like, yeah, I've got that, you can skip through the video, get to where you need to be. We're going to start with this first question. It says, use a Punnett square to answer the following question. Michael and Kia are expecting their first child. Kia is a carrier of sickle cell, but Michael is not. They see a genetic counselor who tells them that the probability of their child will be a carrier of sickle cell is blank percent, and the probability that their child will have sickle cell is blank percent. So we're going to go down here, and I'm going to start working on this. So Kia is a carrier, which is another way of saying she's a heterozygote for the trait. So I'm going to arbitrarily use A to represent the gene for sickle cell anemia. So Kia would have a dominant copy and a recessive copy. Michael, oops, I'm just going to do Mike because apparently hand and brain are not communicating again, is not a carrier, and that makes him homozygous dominant. Now, we want to know the probability of their first child having sickle cell anemia. Basically, these guys want to know what's the risk we'll have a child who has sickle cell anemia, basically means will be heterozygous recessive for the trait. So we draw our Punnett square, and Kia can give the baby a dominant copy of the gene or a recessive copy of the gene. Michael can give a dominant copy or a dominant copy. Now, we do our cross, and we fill in our squares. Okay. Now, if we look at that, there is 4 possibilities for the genetic combinations they can give to their children. 2 have them being carriers, and 2 have them being homozygous dominant. So if we look here, 2 out of 4 will be carriers. So 2 out of 4 is 1/2, or 50% chance that their child will be a carrier for sickle cell. Now, the second is the probability that the child will have sickle cell. If we look at our Punnett square, we need to have 2 recessive genes to have sickle cell. We don't see that in the possible genetic combinations they can give their children, so that's going to be 0%. Now, and remember, sickle cell is an example of codominance, so it's possible for carriers to have a sickle cell crisis, but it really takes extreme circumstances for them to have that. Whereas these homozygous recessive, it does not take much to trigger a sickle cell crisis. Now, in our next question, we have curly hair is autosomal dominant trait. I'm going to represent that with a capital C. Straight hair is an autosomal recessive, and we're going to have that with a lowercase c. Curly hair shows incomplete dominance. Heterozygotes have an intermediate phenotype of wavy hair. People with curly hair